This is still in the idea of what is a derivative and what are we doing with derivatives. I want to talk about what notations we use for derivatives. We've been using this F prime notation, but it's not the only notation we use. And so I want to make sure you know what the other notations are that we use. So first off, sometimes we don't need to use F prime. Sometimes we could use Y prime. If we don't like F, we can use Y. Remember, F and Y are the same thing. They both mean functions. Another notation that we also use besides the Y prime and the F prime is this dy over dx. There's reasons we can use both of them. They are interchangeable. They mean the same thing. It's just what somebody feels like writing. If you like the F, you can write df dx instead. A nice advantage of the df dx is that we can actually pull the F sort of out of it and have d dx of it, the function. So it's just a quick way to write derivatives that way. A newer one that we're seeing now is this d of f of x, or d sub x of f of x. And what we like about these is the d, the dx, and the d sub x, they're what we call differential operators. So they're just another way to think about derivatives and just a different way to think about what's going on, and they're kind of operating on that function. If you want to evaluate your derivative at a certain point, then we can actually write f prime of a, and that's a really nice way to do it. And that's what we do like about the f prime notation, is that you actually know inside if it's an x or an a or something. So this just means you find the derivative first and then plug the a value in when you're done. If you want to use the dy dx notation, then you would write dy dx, but then there's no place to put the x equals a. So we actually put this vertical bar, and then we say x equals a. This means find the derivative and then evaluate that at x equals a. Now the question, of course, comes up is, why do we have two different notations? And it goes back to who invented calculus. So calculus was invented in the late 1600s, early 1700s, actually mostly the late 1600s, by Sir Isaac Newton and Gottfried Leibniz. Now, Sir Isaac Newton is from England. Gottfried Leibniz is from Germany. Leibniz published his in the late 1600s, and Newton suddenly went, whoa, 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 you can't get credit for this. I actually invented this a long time ago. I just never published. And Leibniz is like, well, I don't care. I published mine. You didn't publish yours. I get credit for it. And there was a big controversy about who should be given credit for this. The Royal Academy of Sciences in Britain actually decided to investigate who should be given credit for it. And it turned out that they came back and said Newton should be given credit for coming up with calculus. I should mention that Newton actually was the chair of the committee that worked for the National Academy of Sciences. And so he basically told them to give himself credit. And Leibniz was actually in Germany, and the continent decided to do an investigation on their own. And they investigated and they said, no, Leibniz should get credit for it. Today, we just give both credit for it. We know that they both did work on it. We've used both since then. And so we give credit for it. They both had their own notation. Newton's notation was to call it F with a dot over top of it. It's probably where the F prime notation came from. The dot seemed like it got a little cumbersome. So the prime is a little bit less cumbersome. He also called his fluxions. The Leibniz called his derivatives and dy dx. The reason he called it dy dx is because if you think about what we're doing here, if you take up the derivative, the definition of the derivative is the limit as h goes to 0 of f of x plus h minus f of x all over h. We also have the notation of the limit as delta x goes to 0 of the change in y over the change in x. This was actually the notation that Leibniz used, and this is where his dy dx came from. And so this notation we still see today, we still use it. Leibniz actually kind of in a way is credited with inventing calculus because we still use his notation. Newton's isn't really used, though the F prime probably came from his, but we definitely call them derivatives and not fluxions. So that was the notation we used and where we came up with that notation.